textbooks out and open to page 315. You did pages 315 to 316. Numbers 1 through 11, 14 through 18, and 23. We're wrapping up matrices today and moving on tomorrow to a new chapter. So let's go and quickly take a look at these, make sure we are good to go on all things matrices. There's 1 through 11, there's 14 to 18, and there's 23. Okay. All right, let's take a look. Number 1. What was element A22 in the matrix, Kendall? 5. What is element A13 in the matrix, Michael?
-4.
-4. What is the element number that 3 would be here? Matt? I'm sorry? Well, not B23. It's in row 2, column 2. So it should be B22 for number 3. Looking at your textbook there. You see it now? Okay. For redemption then, Maddie, the -4 would be in what spot? B13. There we go. Let's see, number 5. What did you get when you added those 3 matrices together? Genesis?
4, 7, 2, 4.
4, 7, 2, 4. And again, remember, matrices can only be added, class, if same dimension, same size, right? If they're the same size, you can add matrices. They don't necessarily have to be square matrices like we see here, but they have to be the same size. Number 6, what did you get when you added, Abby?
-4, 3, 3, 3.
There we go. -4, 3, 3, 3. Number 7, is matrix B the additive inverse of matrix A? What does it take to be an additive inverse? Audrey? Brandon? What's an additive inverse? All the signs change, and that's it, right? So did all the signs change in number 7, Audrey? No, that 8 there, and the 4 didn't change signs, and they changed the 3 to an 8. No, it's not an additive inverse. Again, multiplicative inverse, that's a lot more work, isn't it? Right, we have to actually multiply, see if we get the identity matrix, flip them around, multiply again, see if we get another identity matrix. Additive inverse is really easy to spot. Number 8 then, are those additive inverses, Brandon?
Yes.
Yeah, every single sign change, so those are additive inverses. Number 9, it says to subtract. Do we ever really subtract, Michael?
No.
We
Add the inverse.
add the inverse, or in this case, the additive inverse. So we had to do that in the parentheses first here in number 9. Once we got that, take the additive inverse of that to add to the first matrix in number 9. What was your answer, Kendall?
-4, 18, -14, -6, -7, 16.
No. And I'm wondering if you missed a minus sign somewhere. Genesis?
Totally different answer.
Yeah, you should get totally different answer. What did you get for number 9?
8, -4, -8, 4, -13, 4.
You got a couple correct values in there, but not all of them correct. Maddie?
8, 4, -8, 6, -3, 8.
There we go. How many had 8, 4, -8, 6, -3, 8? Okay, so I just managed to call in the wrong people here. Let's take a look. Actually, it's the right people from the perspective of if we want to make sure we understand what we did wrong, we can fix it. And so let's do that real quick here. So I imagine it's possible people watching could also have the same struggle. So we got a parenthesis. We've got a 7, -4, a 5, 5, -3, -2. And I'm not going to put a minus sign. I'm going to put plus, and I'm going to go through and put the inverse. So -6, 7, -3, -6, -2, +4. And so we need to add here first. Kendall, let's ignore this for just a moment. Let's just get this sum matrix right here.
1, 3, 2, -1. -5, 2.
There we go. But again, it says subtract, so we're going to change that to adding, and we're going to take the inverse of everything that Kendall said. And then we're going to add again. Genesis?
8, 4, -8, 6, -2,
-3,
8,
And there we go. And that's the answer, I believe, that Maddie just gave us. Is that correct? All right, otherwise I copied something wrong. And that's been known to happen from time to time. Questions on number 9. Do we see it now? All right. Was it a process error that we just did something wrong, or a mental calculation error?
No, it's a process.
Process error, but you understand the process. Okay, Genesis?
I didn't add the inverse.
Didn't add the inverse, you just added straight up. Okay, then it makes sense now then. All right, on number 10, again, adding the inverse, but this time we only have to do it once, not twice. Abby?
1, 2, 1, -2, -4, -1.
Good. 1, 2, 1, -2, -4, -1 is correct. And then number 11, we had to multiply a scalar here, and it was just a 2, and should be pretty straightforward there. Audrey?
6, 4, 8, 2.
6, 4, 8, 2 is correct. All right, any questions on the 1 through 11? This is pretty basic stuff. Any questions, though, 1 through 11? Anyone perfect so far on the homework? Oh, a few of you are. Excellent. All right, so the 1 or 2 things we've missed so far, we understand now. All right, number 12 and 13 we skipped. 13 I just felt was redundant, and 12 is annoying with all the halves, so, you know, that's me being merciful. I take cash gifts in appreciation. All right, number 14, we had to follow order of operations here. So that involved a scalar multiplication, a subtraction or adding the inverse, and then another scalar multiplication. What was your final answer, Brandon?
3, -6, -3, -18.
Wow, great job. How many have the same thing? 3, -6, -3, -18. You got it all perfect. All right, let's take a look here then. We have the 3 that's going to get multiplied at the very end. First, though, we've got a multiplication by a scalar. And then we've got, it says subtract. I'm not even going to copy it that way. I'm going to copy it as adding the inverse. So, Abby, what should I write in this matrix here?
-5, -6, 7, -4.
There we go. But I can't add until I multiply first. So the multiplication comes before in order of operations. It is within the parentheses. So I'm going to keep the 3 for now. I'm also going to leave this here for just a moment. What does this become?
6, 4, -8, -2.
And rather than recopy, because I am that lazy, I'm going to add these together to get what new matrix in here?
1, -2, -1, -6.
And then we multiply the 3, and that's where we get.
3, -6, -3, -18.
And I believe that's the answer that Brandon just said. All right, questions on this? All right, look, turning the page then, number 15. You weren't actually multiplying. You were just answering, could you multiply? And number 15, yay or nay, can you multiply? Michael?
No. Wait, yes.
Okay, why is it yes?
Because they are multiplicable.
They're multiplicable?
4 and 2 and 2 and 4, they match.
Oh, careful. It's 4 by 2, but not a 2 by 4. The first is 4 by 2, the second is...
6.
And the second is 2 by 6, so you can multiply. What would you get if you multiplied?
4 by 6.
And aren't you glad we didn't have to? Now, Genesis, did you... We're not doing that again. Brandon, did you multiply them?
Yeah, but I stopped when I got to the adding part.
You got stopped when you got to all the part. You did all the partial products, you just didn't finish it. Oh, man, I was going to be really impressed. I wasn't going to know if the answer was right or not because the book doesn't have it. I ain't working it, but, you know, I'm still going to be impressed. Number 16. Can we multiply those together, Kendall?
No.
Because the first is a...
3 by 4.
And the second is a
3 by 1.
3 by 1. Inner dimensions don't match. You can't multiply them. So the answer there was no. Number 17. Both 2 by 2s. You certainly can multiply those. And what did you get for number 17, Genesis?
0, -6, 2, -6. I treated it like an addition.
You treat it like an addition problem, but with multiplication involved. Let's take a look at it, because, again, we've had a weekend here. Let's go ahead and refresh our memories on the multiplication of matrices here. We got the 1, -3, the -2, 2, and multiplied by 0, 2, -1, -3. All right, so we do know our answer is going to be a 2 by 2, not because you always get what you start with, but because that's what the outer dimensions are. So here's where I put that big plus sign in the middle. And remember, we go row times column to get what two partial products?
Oh, okay. 0 and -4.
Well, you're multiplying, remember. Multiply to get 0, multiply to get Negative times negative,
Oh, 3.
positive 3. There we go. And then we're going to also multiply down here. What two partial products do we get?
2 and 9.
Good. And then this row goes down the first column,
0, -2.
and then down the next column.
-1, -6.
All right, so when we add the partial products together, what should our answer have been?
3. 11, -2, -10.
There we go. And how many had that answer? For number 17. All right, number 18. We have a 2 by 3 and a 3 by 2. And the inner dimensions match. We're going to wind up with another 2 by 2. Maddie, what was your answer?
4, 2, 2, -3.
Say that again.
4, 2, 2, -3.
Really close. You were only off on one element. I'm betting it was probably a negative sign error. Abby?
4, -8, -2, -3.
You were off on two elements.
4, -10, 2, -3.
There we go. 4, -10, 2, -3 is our answer. Let's take a look at our multiplication and see if we can figure out where the mistake happened for a couple of you. How many did get that answer though on 18? All right, so a few of us had missed it then. Let's take a look here. Again, we've got a 2 by 3 and a 3 by 2. That tells us our answer is going to come out to the 2 by 2 matrix. So again, plus sign. We're going to make it a little bigger because we're going to have 3 partial products in each portion. All right, so Maddie, let's take you going down the first column
0, 6, -2.
and then down the second column.
2, -6, -6.
All right, and then Abby down the first column
0, 2, 0.
and down the second column.
-1, -2, 0.
All right, and then when we add the partial products together, Michael, we get
4, -10, 2, -3.
4, -10, there's 2 and -3. All right, so did we figure out where we made our mistakes? Those few of you who missed it, did you find it? Was it just a sign error?
No, I had those right, but in my head.
Just mental math. Okay, you're human. I can't criticize after the lesson we had a couple days ago. Questions on this? Questions on this? All right, that was 18. All right, we did not do number 21 and 22. We're going to go back and get 21 in just a moment. But this, whether or not a matrix is an inverse of another matrix, remember, for multiplicative inverse, how was that figured again, Audrey?
Multiplication.
Mm-hmm.
You end up with zeros and ones.
What do we call that if you get zeros and ones, class?
Identity.
Identity matrix. Now remember, we said the ones are going to be in what we call the main diagonal, and then everywhere else zero. So if we get an identity matrix when we multiply them, and then that's the first step. Same song, second verse. Multiplying again, only the opposite direction. We still have to get the identity matrix. If we get it both ways, they're inverses. We'll look at that in just a moment, but we'll skip down to number 23. We had a system of equations, and this is what we've been working on most recently, was solving a system of equations using Gaussian elimination in a matrix. And the first key is to, technically, we don't do this because we're lazy, right? We find the fast way. But technically, we would want to set up 2 matrices and then merge them together. The first matrix in number 23 would be 1, 1, 1, 2, 3, 4, -3, -4, -4. What would we call this matrix? Anyone? Good, the coefficient matrix, because it's got all the coefficients of the variables. And then we'd set up a second little column matrix, and it would be 2, -3, -3, for instance, in number 23. What would we call this matrix, class? The constant matrix, because it's got all of the constants. But we would merge these together, remember, into a single matrix, just separated with a line to separate the 2 matrices. And collectively, we refer to this merged matrix as an augmented matrix. Okay, and again, for our purposes, we said phooey on writing the coefficient matrix, then the constant matrix, then the augmented matrix. We too lazy for that, but you do need to know the terms still. We go straight to the augmented matrix. I assume everyone had this. Show of hands, yes, you have that matrix. That also tells me I copied it correctly. That's really why I ask. All right, and so the key, remember, for the augmented matrix to solve by Gaussian elimination is that the first element has to be a 1. Good news, it already is. Second thing is we have to get underneath the main diagonal. So these terms here, assuming we've got a three variable, 3 equation set, these 3 variables all have to become zeros. So you got to start with a 1 and everything under the main diagonal has to become zeros, and that's where creativity takes over. Kendall, what might we do to get a 0 somewhere?
You can multiply the top by -2.
All right, which temporarily makes it become
-2, -2, -2, -4.
all right, and then we're going to take that we multiply the -2 through, and we're going to put it with row 2, and that's going to give us a new row 2, because I really don't want row 1 to change, do I? I like row 1. I like 1, 1, 1, 2. Those are nice, easy numbers. So it's only a temporary thing, remember, that we multiply the -2, but it allows us to produce a new row 2.
0, 1, -2, 2, and then -7.
There we go. And what else could we do here toward the beginning, Genesis, to get another 0 or more?
Do a positive 3 on the bottom.
On the bottom, that would give me like negative.
Well,
On the top, right? On the top, right? We might write it down here underneath, though, right? What do we get when we put the 3 through the top?
3, 3, 3, 6.
Good, and then we're going to use that multiplication row and the bottom row to get a new bottom row. Right?
0. -1. -1.
All right, and the final thing, remember, everything under the main diagonal needs to be 0. This has got to become a 0, and it really couldn't be easier, Maddie. Yeah, just add these 2 rows, but we're going to leave the top row. We're going to leave the middle row as is. It's just the bottom row becomes the sum of these 2, so it becomes. And at this point then, it really couldn't be any easier, because when you plug in the z and the equals, obviously class, z equals -4. You're going to plug in the -4 right here to get, move it over as a +8 to get y equals 1. And then we're going to plug in the 1 for the y, the -4 for the z, and when we solve for the x, we end up getting class 5. How many had 5, 1, -4? For your answer there on number 23. All right, questions on that?
I just lost a negative on a 7.
Just lost a negative, okay? And so your answer was a 15 for the y, and that meant, oh goodness, -9 for your x. Okay, so one small mistake, very few points off on a quiz or test. All right, good. Any other questions, comments on 23? All right, I want you to do 21 and 24 now. 21, determine are those inverses, and then 24, solving by Gaussian elimination. We're there on page 316. Do you not have multiplicative inverses? Figure it out, and then solve the matrix.
Michael Scott. Brandon's got it. You looked like you were deep in thought. So I figured you were still working, and I realized, no, he's not deep in thought, he's done. He just is such an intelligent young man, he just has that thoughtful look about him.
He was probably thinking about his lunch.
Was it that good?
No.
Or was it non-existent?
He's non-existent.
I'm sorry. You left it at home?
Yeah.
That's a sad day. Did you have good friends who shared with you, like Michael?
He doesn't want what I ate.
Never mind. Just a couple minutes longer, and then we'll take a look at this. Abby's finished as well. Maddie's finished. And this not being April Fool's Day, these really are the people who are finished. Randall's finished. I played like the first 5 or 6 minutes of Friday's lesson for my wife to watch because I thought it was fun. I liked it. She appreciated it somewhat.
We take cash.
Okay, we'll trade. Your fun joke for my easy problem. For sake of time, pencils down. Even if you're not finished, let's take a look at these. Now, to be fair, you should not have done as much work as I did. I showed it for the sake of an example in which it might actually work out. We should start by multiplying a times b and get your partial products. And if it works out to a 1, a 0, and a 1, then you go on to the next step, which is to rewrite a and then multiply this direction, right? Row down column, and get your BA partial products. And again, if they come out to 1, 0, 0, 1, then you've got, yes, inverses. But the very first step, class, we should have known right away, no, it doesn't give you a 1. So are they inverses? How many figured out on the very first set of partial products, not inverses? Good, you should not have done this much work. All right, did we get the correct coefficient matrix, column matrix, and therefore the correct augmented matrix? Any questions? Okay, that also tells me I copied it right. All right, good. So at this point then, we've already got the 1 to start. Will that always be the case? No. If it weren't the case, again, we figure it out. In fact, for instance, you could add these two columns, these two rows together to get a 1, couldn't you? If you had to do it that way. We didn't have to do it that way. So the 1 is good, and then again, these 3 numbers need to eventually become zeros. The easiest one, though, I see is right here. Because if I just add the 2 rows together, class, I'm going to get a 0 for my first number. So I like my top row. I have no issues with that, but I'm going to take the sum and get a new middle row. Audrey?
0, 1, -1.
All right, and then if I wanted a 0 right here, I might put these 2 rows together, but multiply the middle row, class, by a 2. Okay, for instance, the original row had the -1 here. That might work really well. That would change my middle row. And I'm going to write it down underneath here. What does that middle row become if I multiply a 2 through the middle, Brandon?
-2, 0, 4, 6.
All right, and then if I add these 2 together, that can give me a new bottom row to get
0, -2, -1, 6.
All right, so now I've got a 1 with 2 zeros. Now I've got to put these 2 together to make a 0 in the bottom. Now what will I do, Michael?
You multiply the middle row by 2.
to temporarily get what middle row?
0, 2, negative 2, negative 4.
And I'm going to put these two rows together to get a new third row. Now I like the 1, 1, negative 3, negative 9. I like the 0, 1, negative 1, negative 6. But my bottom row is going to become
0, 0, negative 3, negative 6.
all right, and once I've got the 1 and the zeros, I plug in the z and my equal sign if I really want to. And I'm getting class that z equals 2. And then I plug in the 2 and the y, and it equals, and I'm getting that y is equal to negative 4. And I plug in the negative 4 and the 2, and I end up getting that x is equal class to 1. And so 1, negative 4, 2 is our answer. Now, you didn't have to do it the same way I did. So your ending matrix might not be exactly like mine. Excuse me, ending matrix may not be exactly like mine, but the answer still should have been the same. How many had 1, negative 4, 2? All right, questions from those who didn't?
I got negative 34 and 14. I was trying to figure that out.
So somewhere the numbers just got really off. Do you see the easy way that we could have done it? I can always look for the easiest way possible. We're going to do one more in just a second. Any other questions on these? All right, back to page 292. Go back to page 292 and do number 15. Page 292, number 15. But, so I put the negative 3 through, and you can see the step. Now, when I put my negative 3 here, I initially had negative 30, which was messing me up. But I wouldn't trust that to do it by hand. Yep. And it doesn't take that, honestly, it takes almost longer
if you try to do it in your head, you're like, wait, what was that number again? Oh yeah, that was this number, and then that's going to be this number. Probably better off just writing them. Copier. Gotcha. Hate those. Hate copier. And negative sign errors. I made one of those on this one. You had you put a positive or a negative 30 right there. Yeah, I'm like, hey, it works out great too, and I'm all on a roll, and I'm like, that's a weird answer, but maybe it's right. And fortunately, I have the luxury of checking my book and be like, nope, not right. Good news is, that same error on the quiz or test, it's just a negative sign error. Everything else was flawless. It wouldn't be a lot of points off, even though everything was literally wrong now. So again, it's kind of when I grade, I go off the, well, let's assume this was correct. Did it make any further errors, or would have everything been correct based on that? So makes it a pain to grade, but I think it's the most fair way to handle it. Questions? Feel like we got this Gaussian elimination thing? As long as we're careful. Maybe show our work. Questions? All right, cleared us except for pencil, paper, calculator. Pencil, paper, calculator. Everything else away.
Are you sure?
The strategy tip, based on what I just said a moment ago, if everything else is right except for one small error, I'm going to grade based on that. If you were to get a crazy answer, the odds are you made a small error. Don't try to go back and fix everything. There is not time. Leave the crazy, nutty answer you got and move on to the next problem. Does that make sense? Because probably you just lose a few points. Don't risk a lot of points to try to save a few. All right, first last name at the top of your paper along with today's date, which is April 4th. 4/4/22, and this is quiz 30. Quiz 30. Not a long quiz. 5 questions, 2 systems. That's it. All right, so 1 through 5, answer the questions, or do what it says, I suppose would be another way to put it. Do what it says to do for 1 through 5. Number 6, use a matrix to solve. Number 7, use a matrix to solve. Again, if you get stuck on 6, move on. Don't waste time. I'm going to write the homework on the chalkboard and we'll end the video here.